everyone. Hope all of you are doing well. In the last 3 videos, we were discussing the previous questions and answers from units and measurements. In this video also, we are continuing with the same chapter. We are discussing almost 10 years of question paper in chapter wise. If you have not subscribed the channel, please subscribe. Okay, can we move to the first question? This question is asked in the year March 2013. Also, this is a 3-mark question and 2 parts are here. Okay, the first one is having 1 mark and the second question carries 2 marks. Now we can move to the question. Velocity of sound depends on density rho and modulus of elasticity E. The dimensional formula of elasticity is given as m L raised to minus 1 T raised to minus 2. The first question is state the principle of homogeneity. The second one, using the above principle, arrive at an expression for the velocity of sound. Also, it is given that we can take k that as a constant and k value is given as 1. Okay. Here the first question is to state the principle of homogeneity that we have already discussed in the last videos. Okay. And the second question, we have to find the expression for finding the velocity of sound by using homogeneity principle. Are you ready to answer the question? Okay, first of all, we have to state the principle of homogeneity. That is, the dimension of the same fundamental quantity must be the same on either side of the equation. Okay, so this principle can be used to find the equation for velocity of sound. Now we can move to the second question. Here it is given that the velocity of sound depends on the density and modulus of elasticity. So how we can represent it? That means the velocity can be represented as V and density as rho, modulus of elasticity E. So how we can connect these three? V is the velocity. That means it depends on rho and E. So that we can write it as V proportional to rho and E. Here we have to apply the principle of homogeneity, right? So that we don't know the dimension of these quantities, how much will be the dimension. So we can just take it as A and B. So that can be written as V is proportional to rho raised to A and E raised to B. Here we have to get the equation for velocity of sound, right? So here we have a proportionality sign. How we can convert this into equal to sign? Yes, we can multiply with a constant. So that constant is given as k and that value is 1. Okay, so the next step how we can write? That will be equal to V is equal to k into rho raised to A, E raised to B. There is no change for that. Only k we are multiplying. But it is given that the k value is taken as 1. So what will come? Yes, that will be V is equal to rho raised to A into E raised to B. Now we have the equation as V is equal to rho raised to A, E raised to B. Right. Now in order to apply the principle of homogeneity, we have to find the dimension of each term in LHS and RHS. Okay. So what will come in LHS? That is velocity. How we can write velocity? That is displacement by time. That will be L T raised to minus 1. And what is coming in RHS? That is rho. Rho is the density. Density will be equal to, how we can find density? Yes, that is mass by volume. Okay. So mass by volume means m by L cube. Right. So how we can write it? M L raised to minus 3 whole raised to A. And what about E? E is the modulus of elasticity and its unit is Newton meter raised to minus 2. So that the dimension is m L raised to minus 1 T raised to minus 2. So that we can write down here. That will be L T raised to minus 1 is equal to m L raised to minus 3 whole raised to A into m L raised to minus 1 T raised to minus 2 whole raised to B. Now we can write down the dimensions of similar terms together, right? So what will come in LHS? LHS has only m0 L T raised to minus 1 because only V was there, right? And then what will come in RHS? RHS m in the first term m is there, and that is m raised to a, and in the second term also m is there, that will be m raised to b. So how we can write, that is a raised to m into a raised to n, so that will be a raised to m plus n, right? So how we can write m raised to a plus b. Now what about the powers of L? L has minus 3 into a, so L raised to minus 3a. Then in the second term it has L raised to minus 1 whole raised to b. So what will come? L raised to minus 3a minus b, right? What about t? T, in the first term there is no power for t, right? In the second term it has minus 2, so minus 2b is there, so t raised to minus 2b is coming. So finally we will get the equation as m0l t raised to minus 1 is equal to m raised to a plus b L raised to minus 3a plus b t raised to minus 2b. Now according to homogeneity principle, we have the dimension of the same fundamental quantity must be the same on either side of the equation, right? So how we can equate here? Here we have the dimension of m as 0 in LHS and a plus b in RHS. So how we can equate? That is a plus b will be equal to 0, right? In a similar way, what about the dimension of L? L has minus 3a minus b in RHS and 1 in LHS. So how we can write? Minus 3a minus b is equal to 1. And what about the last term, that is b, that is t raised to minus 2b, and on the other side it is minus 1. So how we can write? Minus 2b is equal to minus 1, or how we can find b from that? B will be equal to 1 by 2. Here we can name a plus b equal to 0 as the second equation and minus 3a minus b equal to 1 as third equation. Okay, now we have b is equal to half, right? So suppose we are substituting the value of b in equation 2, which is equation 2, a plus b equal to 0. So what we will get? A plus half is equal to 0. So how we can find a? A will be equal to minus half, right? So that value, now we have a and b. Can we substitute in first equation? The equation is v is equal to k into rho raised to a e raised to b, right? Here we have k is equal to 1. So what will come? V will be equal to rho raised to a. A is minus half, right? So rho raised to minus half into e raised to b. B is half. So what we will get? V will be equal to rho raised to minus half into e raised to half. Okay. What is e raised to half? That is root e, right? So what about rho raised to minus half? That will be root of 1 by rho. So how we can write it together? V will be equal to root of e by rho. So this is the equation for finding the velocity of sound. Is it clear? Now we can move to the next question. The question is also asked in the year March 2013. This is a 1 mark question. The question is, pick out the fundamental unit from the following. The options are second, meter per second, Newton and joule. Okay. So what is the fundamental unit? We know that the 7 fundamental units are there, right? What are the fundamental units? Meter, kilogram, second, ampere, Kelvin, cantilla and mole. So which will be the fundamental unit in these 4 options? Yes, that is second. Okay. So that now we have completed the March 2013 question papers. Only these 2 questions are asked in March 2013. Now can we conclude? If you like this video, please like, share and subscribe. Thanks for watching.